The day the Earth stood still, a total decimation of the living world. The cessation of Earth's rotation is not merely a scenario for a disaster movie. It is the absolute destruction of every physical system that makes our planet habitable. To truly grasp the magnitude of this event, we must analyze the process across 5 distinct stages, from the raw mechanics of inertia to the global restructuring of the climate and the eventual death of the biosphere. 1. The kinetic shock, the first seconds of catastrophe. Earth rotates on its axis at approximately 1,670 kilometers per hour, 1,037 miles per hour, at the equator. We do not feel this speed because we move in perfect synchronization with the planet, much like passengers on a smooth-running train. But if the planet were to suddenly slam on the brakes, Newton's first law of motion, the law of inertia, would take command with lethal force. Horizontal flight. The instant the Earth's crust stops, everything not anchored into the tectonic bedrock will continue moving eastward at 460 meters per second. People, buildings, vehicles, and the very topsoil will be launched toward the horizon. This is 1.5 times the speed of sound. Scale of destruction. Cities will not simply collapse. They will be erased from the surface. Skyscrapers will turn into clouds of debris, hurtling parallel to the ground. At latitudes like London or Moscow, the speed would be slightly lower, around 1,000 kilometers per hour, but still more than enough to pulverize any object into dust. Geological shift. The sudden halt of the crust would create colossal stresses within the planet. Tectonic plates would slam into one another with unimaginable force, triggering earthquakes of magnitude 12 or higher, reshaping continents in mere minutes. 2. The supersonic atmosphere. The scorching gale. The air is also matter, possessing mass and inertia. If the surface of the Earth stops, the atmosphere will continue to spin. Inertial winds. A global hurricane with wind speeds exceeding 1,600 kilometers per hour would emerge. For context, the most destructive tornadoes on record have wind speeds around 500 kilometers per hour. This stoppage wind would scour vegetation and soil down to the bare rock. Heat and plasma. Friction between the stationary crust and the supersonic air would generate a staggering amount of heat. Near the surface, the air could reach temperatures where organic matter instantly ignites. Vast forests and the remains of cities would be reduced to ash in seconds. Atmospheric loss. These powerful air currents could literally splash beyond the reaches of gravitational retention, causing a significant portion of our oxygen-nitrogen mix to be lost to space forever. 3. The Great Ocean Migration, Flood and Exposure. Earth is not a perfect sphere. Due to its rotation, centrifugal force pushes water toward the equator, creating a bulge about 8 kilometers, 5 miles high. Collapse of equatorial water. As soon as rotation ceases, the centrifugal force vanishes. The only remaining master is gravity, which is strongest at the poles, since they are closer to the center of mass due to the planet's oblateness. Migration to the poles. Massive volumes of water will begin to flow away from the equator toward the north and south poles. This will be a planetary-scale tsunami that drowns everything in its path. 2 oceans and a ring continent. Eventually, Earth will be left with 2 isolated polar oceans. Along the equator, a continuous strip of land will be exposed, an equatorial megacontinent. The Mariana Trench would become a dry valley, and Mount Everest would stand even higher relative to the new sea level. 4. The thermodynamic hell, a year-long day. Once the dust settles, a new reality begins. If Earth stops rotating relative to the stars, its only way to complete a rotation relative to the Sun is to finish its orbit. This means one day will now last 365 standard days. 6 months of heat, the day side. On the side facing the Sun, a permanent day begins. Temperatures would soar to plus 100 degrees Celsius, 212 degrees Fahrenheit, and beyond. Polar oceans would begin to evaporate intensely, creating a thick, suffocating layer of steam. Life on the surface would become impossible due to heat and radiation. 6 months of ice, the night side. On the reverse side, a permanent night takes hold. Temperatures would plummet to minus 80 degrees Celsius to minus 100 degrees Celsius. Atmospheric moisture would fall as massive layers of snow, followed eventually by the freezing of carbon dioxide itself. The Twilight Zone. The only place where temperatures might be tolerable would be a narrow Terminator strip, the border between day and night. However, due to the monstrous pressure and temperature differentials between the hemispheres, eternal violent storms would rage here. 5. Death of the magnetic shield. Cosmic sterilization. Earth's magnetic field is generated by a dynamo effect in the outer core. The churning of liquid iron. Stoppage of the dynamo. Without the planet's rotation, the convection currents in the core would be disrupted, and the magnetic field would begin to weaken rapidly. Solar wind. Without the magnetic shield, Earth becomes defenseless against solar radiation and cosmic rays. The solar wind would begin to strip atmospheric molecules into space. Radiation background. The surface would be sterilized. Even if survivors existed in deep bunkers, venturing to the surface without heavy shielding would mean instant radiation sickness. Earth would eventually resemble Mars, a cold, breathless, and lifeless desert. The day the world stood still. Part 2. The biological and geopolitical aftermath. If the first part of our analysis covered the physical and mechanical destruction of the planet, Part 2 focuses on the unraveling of the fabric of life, the remnants of human civilization, and the long-term destiny of Earth as a cosmic object. A rotational halt is not the finale. It is the beginning of a torturous transformation that would turn the blue marble into something unrecognizable. 1. Biological collapse. The end of circadian rhythms. Life on Earth has been built around a 24-hour cycle for billions of years. Almost every living organism, from bacteria to the blue whale, possesses circadian rhythms, internal biological clocks. Hormonal chaos. The human body regulates sleep, metabolism, and cell regeneration using melatonin and cortisol, levels of which are light-dependent. In a world where a single day lasts 6 months, these biological clocks would go haywire. This would lead to rampant insomnia, severe depression, and systemic immune failure for the few who survive the initial inertial winds. The death of flora. Plants are not adapted to 182 days of continuous solar radiation. Even if they don't burn, their photosynthetic apparatus would become overloaded, leading to the accumulation of toxic free radicals and eventual death. Without plants, all food chains collapse. Species caught on the dark side would perish even faster from the extreme cold and the impossibility of photosynthesis. 2. Geopolitics of the void. Where to seek refuge. If humanity had time to prepare, for instance, if the slowdown occurred gradually over decades, the political map of the world would become a nightmare. The battle for the Terminator. The Twilight Zone. The narrow strip between the scorched desert and the frozen hell. would become the only habitable land left. Nations located in this zone would become the new superpowers, while the rest of the world would be forced to evacuate billions of people into these thin slivers of territory. Subterranean cities. Because the surface would be blasted by radiation and battered by hurricanes due to temperature extremes, civilization would move underground. The energy of the future would rely solely on nuclear fusion or geothermal sources, as solar panels on the day side would degrade rapidly from the heat, and the wind would be far too unstable. 3. Atmospheric segregation, the death of breath. The stop of rotation would cause the gases in the atmosphere to redistribute in lethal ways. Nitrogen ice. On the night side, where temperatures would drop to extreme lows, atmospheric gases would begin to condense. First, all moisture would freeze out, followed by carbon dioxide, dry ice. Eventually, as temperatures fall further, the atmospheric pressure on the dark side would drop so low that oxygen and nitrogen might turn into liquid or frost. Global vacuum. This creates a colossal pressure differential. Air from the day side would rush toward the night side with terrifying force to fill the vacuum, creating permanent supersonic winds in the Terminator zone. Living there would be akin to living inside a running jet engine. 4. Lunar drama, orbital chaos. The moon orbits the Earth, and its path is maintained by a complex balance of forces, including tidal friction caused by Earth's rotation. Approach or retreat. Normally, Earth rotates faster than the moon orbits it, which causes the moon to slowly retreat by about 3.8 centimeters per year. If Earth stops rotating, this mechanism reverses. Tidal forces from a stationary Earth would begin to act as a brake on the moon. The satellites fall. Over millions of years, the moon would begin a slow, spiral descent toward Earth. Eventually, it would either reach the Roche limit and be torn apart, forming a ring around Earth, like Saturn, or it would crash into the planet, officially ending Earth's history. 5. Long-term fate. A second Venus or a second Mars? What would become of Earth a million years after the halt? The Venus scenario. If water vapor, a potent greenhouse gas, is trapped in the atmosphere on the day side, a runaway greenhouse effect could begin. Temperatures would rise high enough to bake carbon dioxide out of the rocks, turning Earth into a hellish twin of Venus. The Mars scenario. Alternatively, if the solar wind strips away the atmosphere due to the lack of a magnetic field, Earth would become a cold, dry, and lifeless rock, scarred by meteorites that no longer burn up in the thin air.